Let's see how to use the 5 key points along with the baseline to do a quick and easy graph of sine of 3x. If all you're doing is putting sine of 3x on a graph by itself, then this is really, really easy. What we want are our 5 key points. So there's 1, 2, 3, 4, and 5 for our marks on the baseline. And we know that it does one complete cycle from on the distance along the horizontal axis from 0 to 2 pi over 3. We're going to draw one cycle of it. So this is 2 pi over 3. It's still sine, and its amplitude isn't being modified. There's no coefficient in front other than 1 that we don't write. So we know it's going to look like sine. It's just going to wiggle a lot faster and do one complete cycle by 2 pi over 3. So we place, now that we have our mark down, we place our 5 key points, 0, 1, 0, -1, 0, and we connect the dots. Nice curves, just like that. Now this might make you laugh because you're saying, well, what's the difference between this graph and sine of x? It looks just the same. We graphed it with the 5 key points just the same. Really, the only thing that we did different was we labeled this part here. And truly, if this is the only graph you're putting on these axes, this is fine. This is everything you need. It's showing the amplitude, it's showing the period, it's one whole cycle. If we needed to move farther or show more cycles in this direction or that direction, plot down 5 more key points. We could go here. This is the first key point. Try to keep the distances about the same. 2, 3, 4, 5 goes off my chart. So 0, 1, 0, -1, and then it'll go to 0 but off my paper here. And that's how you keep it going. Sometimes people ask, how do I know what these markers are? I have this. I want to know what those points are. Well, keep in mind that if this is 0 and this is 2 pi over 3, then that's half the distance. So 1/2 of 2 pi over 3 is just pi over 3. So we know this is pi over 3. And if this is 0 and this is pi over 3, this is just half of that. So it's pi over 6. Now look, this is 1 pi over 6. This is 2 pi over 6. This is 3 pi over 6, so it's just pi over 2. And this is 4 pi over 6, because we just calculated that this distance here is pi over 6, and these are evenly spaced. So it's easy to figure out what those are, and you would just keep adding pi over 6 to each one, this one to get that one, this one to get that one, and so on. So that's easy, and that's the beauty of the 5 key points. And I like to show my students this. I say, look, what if I want to show, let's say I have sine here, 2, 3, 4, 5, and this is sine 1 and -1, 0, 1, 0, down, 0. Okay, here we go. Okay, do I want to show sine of 3x? There we go. Because I took the period of sine and I divided it by the 3, which is what we did with that calculation with the argument. That's wonderful. If you need to graph sine of 3x with other functions on the same set of axes, so let's say we're going to graph sine of x and sine of 3x, you have to be a little bit more careful. First, I know that sine 3x, I get 3 cycles of it in the same cycle as sine of x. So I'm going to make my axis longer. I'm going to make that 2 pi. So there's pi over 2, 3 pi over 2. Okay, where's 2 pi over 3? Well, if we break up this distance into thirds, I'm going to move that over just a little bit so it's a little bit more accurate. I like that better. That distance is more like that distance from here to here. Okay, so where's the thirds? There's about a third, there's about a third. From there to there to there, maybe a little bit less. That's 2 pi over 3. So here's 2 pi over 3. And so if I ignore that pi over 2 mark and say, gee, what do I do? Well, this is going to be pi over 3. This is going to be pi over 6. And of course, we already knew that this was pi over 2. So sine of 3x is going to go from 1 to minus 1. It's going to go 0, up, 0, down, 0. And so we get this. If we want sine x, we look at our key points for sine. That's here and there and there and there and there. So it's 0, up, 0, down, 0, and we graph that in. Now we need to finish this chart to this graph to go all the way to the end to match this one. If we were told to graph both of them from, say, 0 to 2 pi, well, then the next one is 4 pi over 3. We need to go 2 pi over 3 and double that, so that's 4 pi over 3. So that's about here. So we mark that distance there, and we say 0, up, 0, down, 0. 0 up, 0 down, 0. And then the same thing here. 0 up. Oh, we got to put in our 5 key points. 1, 2, 3, 4, 5. 0 up, 0 down, 0. Up. There. So now we've done sine of 3x all the way through the same cycle, or the same distance as the cycle for sine of x, which goes there. Those 5 key points are marvelous. They're just wonderful. You just mark them down, remember the pattern, connect the dots with the curves.